So let's go ahead and get back to our lesson up top before we take a quiz, okay? So here we go. If you look at this first example right here, all right? We're talking about Boyle's law, all right? Boyle's law. Here is your first problem, and I'm going to break them down for you in the simplest form. It says a respiratory therapist compresses 1.5 liters manual resuscitator, okay? Resuscitator, sorry, from an initial pressure of 1.0 atm. If the volume is squeezed down to 0.5 liters, what is the new pressure of the air being forced into the patient's lungs? What you all will notice is that every time I do a problem, right, I try to relate these examples to real life problems because a lot of times students don't understand the relationship. Like, why do you have to know this stuff? So many of you guys are going into the nursing program. That's why I do what I do in terms of making the problems relevant to what you all are experiencing. All right. So you've been given 1.5 liters of the volume, but then it dropped to 0.5 liters. As I shared yesterday, if you noticed here, your volume has dropped by a third. Okay, I can visibly see that, right? So if your volume drops by a third, your pressure is going to go up 3 times the amount. And the predicted answer is going to be 3.0 atms. Now, let's go ahead and solve this problem now so that you all can see exactly how to work this, okay? So remember, the formula for Boyle's law says that P1 times V1 equals P2 times V2, right? That is the formula for pressure and volume relationships with Boyle's law. But even though I give this to you, you got to know how to rearrange it. So we're looking for P2. Sorry, y'all. All right. So I know that since we're looking for P2, my formula for P2 is P1 times V1 divided by V2. Now, all you have to do, like we said before, put the answer, the numbers into the proper format. 1.0 atm times 1.5 liters divided by 0.5 liters. Now, I know that when I cancel out my liters, I'm looking for ATM, right? Let's go back to our calculators. All right. And you've got 1.0 times 1.5 and then divide that by 0.5 and you get 3. Let's keep those sig figs in check. You're going to say 3.0 ATM. And guess what? Our predicted answer was correct. All right. Now, let's go to the next example. All right. We're going to go to the next one. Now, again, all you have to do, y'all, look at the problem, read the example to see what they're asking you to do. The next one, a patient enters a hyperbaric chamber. If a 2.0 milliliter bubble of air is trapped in a patient's IV line at 1.0 atm, what will the volume of the bubble become if the chamber pressure is increased to 3.0 atms? Now, this is a problem. We don't need any air being trapped in a patient's IV line. Absolutely not. Okay. But here's what they gave you. 2.0 milliliters, 1.0 atms, and 3.0 atms, right? Well, I'm going to go ahead and plug this in once again. P1 equals 1.0 atm. P2 equals 3.0 atms. V1 equals 2.0 milliliters. And V2 equals, that's what we're looking for. Now, what you're going to notice here is that your pressure tripled. Look at that. It went from 1 to 3. So because my pressure tripled, that means my volume is going to be cut by a third. All right. Now you're probably wondering, wait a minute, how do you know that? Well, remember, Boyle's law, let me go back up here to remind you. Boyle's law says that they are inversely related to one another. If one goes up, the other one goes down. So if my pressure doubles, my volume is inverse of that, meaning 1 over the 2. So therefore, my volume is cut in half. However, if my pressure goes down, then my volume will go up. So that means if my pressure dropped by 1/3, my volume is going to triple. Okay? So now, what we're going to do is go back to the problem, all right, for number 2. All right, here we go. We're looking for V2. So to get the formula for V2, it's going to be equal to P1 times V1 divided by P2. So let's plug these answers in. No, it won't always triple. Sometimes it could quadruple. Sometimes it could be cut by a half. It just depends. Now, we're working with whole numbers, which makes it easier to identify the answer. But no, it won't always have that pattern. So see, like in this example right here, it tripled, but this one is cut by 1/3. And if I say that this is cut by 1/3, I'm going to predict that the answer is something like 0.66, 6. It just keeps going, right? That's what I'm going to predict this answer is going to be. So, because 1/3 of 2 is about that amount. All right. But again, if you all want to know, how do you get the answer so fast? Check this out. You've got 1.0 ATM, because that's my first pressure reading up here with the data. We've got 2.0 milliliters, and then we have 3.0 ATMs for my second pressure reading. Let's go ahead and cancel out our ATMs. So you've got 1.0 times 2.0 divided by 3, and you get, see, that predicted answer, 0.666, okay? And we're just going to say 0.67 so that we can only have 2 significant digits. So we were right with our predicted answer. Now, although this is not a lot of volume, it's still enough to cause a problem, all right? It's still enough to cause a problem. All right, here is our next example. A suspect is found with 12 ounces or 0.35 liters canister of dusting air used as an inhalant. We know what you're doing, right? Forensic analysis shows the internal pressure was 6.0 ATMs. If the suspect released the gas into a 4.0 liter airtight bag at the scene, what would the pressure inside the bag be? So guys, what I want you all to understand is that when you're reading these word problems, don't get these numbers mixed up with, I don't know where to start. Read the problem the first time and then go back and reread it and start to identify what was given. You're going to either be given pressure 1, pressure 2, B1, volume 1, or B2, volume 2. You're going to be given 3 of the 4 numbers, all right? So the first volume that they gave you here was 0.35 liters. Then the second volume was 4.0 liters. Let's go ahead and write that down. 0.35 liters and 4.0 liters. All right, so we can see that our volume increased. Now, I don't know about what factor, but I just know it did about 10 times the amount. That's what it's looking like, okay? It seems like it went up about 10 times the amount. All right. Now, again, I'm not asking you all to make the predictions initially, but this just helps. So it looks like it's going up 10 times the amount. So guess what? Your pressure is going to drop 10 times the amount. Now, again, how do you know? Well, because if my pressure went up 10 times the amount, approximately, then my pressure, if my volume went up 10 times the amount, then my volume is going to go down by a tenth of that. All right. So we know the predicted answer is going to be less than 6.0 ATMs. Okay. It's going to be less than that. This is the predicted answer. I'm going to highlight this in red. This is the predicted answer. So with that being said, let's go ahead and solve for V2. The formula for V2 is P1 times V1 divided by P2. All right. P1, 6.0 ATM. V1, 0.35 liters divided by P2. On the bottom is that 4.0 liters. All right, so let's make sure Professor TK put these numbers in the right way. P1, 6.0 ATMs. V1, 0.35 liters. V2, 4.0 liters. All right. We're going to cancel out the liters because we don't need those anymore. We did the 6.0 ATMs. We multiplied that times 0.35. Now we're going to divide that by 4.0. And we get 0.525. Okay? 0.525. But we're going to round it off because we only need two significant digits. So 0.53 ATMs. So technically speaking, this did drop by a tenth. This did drop. Look, if you don't believe me, let's plug it into the calculator so you all can see it for yourself. Remember how I said that if my volume increased 10 times the amount, then I know that my pressure is going to drop by a tenth. Let's plug it in so y'all can see what's a tenth of 6.6. And that's approximately 0.6 right there. Close enough, right? So Ashley, I know you mentioned that you all cannot use a calculator, right? I want you to visualize the numbers. So that means if you cannot use a calculator, right, but it's multiple choice, here's what you can do. Okay, well, see, I see numbers all the time. That's why things stick out to me a lot, because I see them all the time. So what I would do is make this 0.40. 0.40 versus 4.0 tells me it's like 10 times that number. 0.40 going up to 4 is like 10 times the amount. Think of this as like 35 cents, and you end up with $4, right? 35 cents 10 times is $4 or $3.50. But, you know, roughly that number, okay? So I know if in volume, if this increased 10 times the amount, then I know that a tenth of that number is going to be 60 cents. Okay. So I'm just trying to get y'all to visualize these numbers and like, just talk, make them similar to money. I mean, I say it all the time. If you think like money, you'll get these problems right. Okay. I'm going to help you out on the next one because we're getting ready to go into Charles' law now. Take a look at this next one.